Good morning, folks. Oh, I had to update the titles, don't I? Doing data viz in C. There. I'll just update the titles. It doesn't update on X, but whatever. We will get back to doing UI in C because it's fun. But for the time being, gotta catch up on some basic stuff. Today's gonna be kind of a chill day. The goal is going to be that we run some baselines, we check through some experiments, we put up some slides, maybe a little basic presentation. That's what we're gonna do. So, to start with, switch over to Stream View. Go that. I think that the first thing we're gonna do warning. Move all this out of the way. Let me see if I can figure out what is finally wrong with this annoying thing here. And I've managed to just fully exhaust myself. Ah well. I have some basic stuff to do anyways. I just have to go find welcome Prime. Okay, so according to these guys, apparently this thing is getting reward. We run co-games. Where the hell's the config? Dude, where is this? Mission and name and config. But where is the trainer? I do not understand this. What else is there to add to the dashboard? Quite a bit. Well, not really quite a bit in terms of features. It just needs to be cleaned up. So I didn't get to update the title for for today. Not what I'm going to be working on probably for a decent chunk of today at least. So I'll show it though really quick. So this is where we ended from last week with the dashboard, right? Really, really nice, fast dashboard, right? But that actually takes real thought to like work on that, and I'm kind of burnt. I did like a full day on Saturday of this, and then Sunday I literally was just lifting weights all day. So easing into the start of the week, the goal is I've got a couple things I got to figure out for these guys on how to get them a decent baseline. I've got like a little demo of some type to put together for a presentation on Wednesday for a lab that I'm working with. I owe a whole bunch of people PR reviews, right, for all the new environments that people have been making. So I can catch up on that. And I'm going to see how I'm feeling after working on just this type of stuff for a few hours. And maybe we'll go back to Viz. So this is like, the story on this is it's a really cool project, but I can just never make heads or tails of their code. So I try to help them as best I can, but it's just very, very difficult for me to figure out where the hell anything ever is, and it always moves around. Okay, so this is hard coded, I guess. What is this? Oh, okay, they just have everything hard coded. And this is mostly taken from me. Okay. Let me see if I can figure out. Actually, I'm just gonna like, hang on. I didn't realize it actually run this whole good hyper. Let me just link them this sweep. Deposited amount. Hey, Martin. He'll reply to me on that. So we'll keep this up. In the meantime, though, actually, you know what? This is a great thing to ask this stream because a lab that I work with, where the students, at least some of them, don't do low-level dev, they've been asking me for a tutorial on PufferLib and like creating high-performance environments. So if you go to the Puffer docs, right, literally right on the docs page, the only thing that's on this whole page, other than this glossary thing, is exactly that. It's a tutorial on writing environments with like full complete code, right? Here's complete code. There's even like a second whole tutorial right here, right, with all sorts of code. It's all commented. So I guess what I want to know from my users is like, what should I do that's going to make this easier for you, right? Like if I were to make some other type of tutorial, what would you want it to be? Is it that the environments are too simple? Is it that I'm not covering them in a reasonable way? Like what can I do to make it easier for people to understand how like quick and powerful it can be to do dev on this stuff? Tutorial type video. So basically people just want video form content then, right? Because like I'm trying to like that's the only thing I can think of. Is to just have something in video form. Well, this is the problem mechanics. I don't either, but it's the most common question I get. And it's like it's a fair bit of code to have to like do in a 20-minute tutorial. Like let's say I wanted to make target, right? Well, this is the thing though. I guess I could have it linked on the website, but every time people ask me this, right, I direct them to my guide. Oops. Maybe I should just go back to working on the visuals. So I have this whole guide here where it's literally been step by step. Read this, write this, do this, read this. And like I take you through everything. Like the less charitable part of me, right, wants to think that this is simply a matter of people wanting video form content because video form content is very easy. You just watch it and you feel like you've learned something even if you haven't. Whereas like you actually have to work through this. Not that hard, but you do have to work through it. You can't just consume it passively. Right? Hey Finn. I will be back to you on that message as well. I look forward to seeing the drone stuff. It's gonna be awesome. I will be back to you soon on that. But yeah, this is I'm very much looking forward to seeing the drone stuff. This will be cool. For the reference Finn, so this weekend I literally all Saturday I was like live stream like I literally did live stream breakfast, live stream lunch, live stream dinner, live stream bed, all the development. And then yesterday I was so burnt out from that I just like lifted weights all day long. And today I'm like semi back, but trying to get my bearings. I had to figure out some paperwork around that thing. Articles adequate. Linked. Just have it. I can definitely link some stuff. Difficult to put yourself in the shoes. It definitely is, right, Gary? I've tried to put most of those, like, if I were starting out, what would help, though? I've tried to put those into 2 different articles, right? These 2 articles, and these are my 2 best received articles as well. This one literally got, like, a stamp of approval from Carmack, which is the highest possible form of praise I could ask for. Heck, I gotta go get that tweet, like, printed and framed. And then this one is, all my best RL advice. I'm sure there are a million other little things I haven't thought of. But I tried to put even like the simple tangential stuff that kind of matters. Anybody else here? I mean, we have a fair few folks. YouTube, Twitch. Is there anything that you would like to see from me in terms of content on getting into building like high perf RL environments? Because I'm supposed to give a tutorial this Wednesday for a lab on this. And if I can make something in the process that would be helpful for more people around here, I'd like to do so. Because, like, otherwise I would just do a walkthrough of this target environment code. I can just try to do this live. You know what? Here's what I'll do, guys. I'm going to start going through this environment live. I'm not great at giving impromptu presentations. I'm actually a pretty good presenter, but all my stuff is very heavily rehearsed and practiced. So I'm just going to go through this impromptu live, and we're going to see whether this is useful to you and in what form, I could change this to make it more useful. Does that sound good? And then just ask me all the questions that you'd like in chat along the way. I'm live on X, YouTube, Twitch. The chats should generally all work. Twitch is lowest latency. YouTube's not terrible. And I just have to fix one small thing so that this demo will work on the current branch. And we'll go through this little tutorial for you all. And this will count as practice for Wednesday, and then this will count as potentially new ideas for better ways to present this information. And this will be a good warm-up for the stream as well, because I'm still pretty exhausted. How PufferLib is in the context, like why it's better. So I've always had a difficult time with this mechanics, because the thing is, I can't really put PufferLib into a box. Like, PufferLib isn't a tool to do X. It's not like a library that's like, Y, but also Z. Puffer is a comprehensive effort for me to advance reinforcement learning in every possible way I think is relevant, right? It's like a comprehensive effort. So what does PufferLib have? It has high performance simulation. It has tooling that makes it easier to do high perf sim. It has vectorization for faster distributed processing. It has a high performance trainer. It has the fruits of algorithmic research, right? It has a high performance hyperparameter tuning setup. There's also like new algorithmic research. It has additional visualization tools, right? It has so many different things in it at this point, and it's all in this like pretty compact package that's pretty easy to get started with. So this is just me setting up a project to advance reinforcement learning in the best way I can think of, and then making it useful for other stuff as well. The simpler explanation I do is really for non-technical people who are not trying to learn this stuff. They just want like the quick 2-sentence thing. Welcome, SPY. And I have to reboot the Docker container. Then we'll do the tutorial. All right, so this environment is target. This is a multi-agent environment. Each puffer is controlled independently. The puffers want to eat stars. You can help me out by starring PufferLib on GitHub. What we're going to do right now is we're going to go through the source code for this, so you can see how simple it is to build a high-performance, even multi-agent environment that trains in a few seconds, where you can actually learn something reasonable like this. And just to demonstrate to you, this works. I'm going to probably have to make one config change. Nope, apparently not. So this is training the agent. You can see episode length going down, which is the time it takes it to get a star. We're going to train this thing for 100 million steps in less than 30 seconds. Okay, there you go. 100 million steps, 26 seconds. It's running a little extra evaluation at the end right now. Okay, it's done. And now I'm going to show you. This is evaling a random policy. So this is what looks like if the model is untrained. Right? And now did I break loading? Oh, okay. Well, hang on. This is come on. Name experiments. Okay, great. Well, lucky me, I have to switch branches. All right, here. Try this one more time. Oops. I was on the wrong branch. Apparently, I've broken loading on the dev branch. Give me a solid RL roadmap. I have an article on that. Right? This article right here gives you everything. Okay. And hopefully this works. There we go. So this is the model that we just trained. In SPY, it's C and Python mostly. But most of the code is C. All the sim code is C. Okay, so here's your model. It's trained in under 30 seconds, 100 million steps. Now I'm going to show you how to build this thing. So first of all, with PufferLib, every single environment has its own folder under Ocean. Ocean is our suite of custom environments. The reason that we put all the environments inside of Ocean instead of like giving you a third-party API that you can just call is because it's kind of annoying to bind C extensions to Python. So if you just do it here inside of PufferLib or inside of a fork, you get to use our build system, and then you don't have to do it yourself. We're going to figure out a way to make that easier eventually, but for now, just do it this way. And then pretty much all the code for target is just right here. Now, there are a few different files in here. Let's start with the Python file. What framework do I need to learn? No frameworks. If you follow both of my articles, though, that takes you through the whole process. It's very minimalistic, this whole project, like very minimal. Like you have PyTorch for the learning side, but like it's not going to be a thing where, you know, it's just a wrapper around some big framework. A lot of this is just very minimal from scratch. Okay, so this target environment here, it's only about a screen of code. Yeah, and then there's this little tiny speed test at the bottom. There's no real logic in here. This is just the Python entry point into the C code. Right here, this is importing the C code. This inherits from our pufferenv, which is like a gymnasium environment, but vectorized. Like a vector env format. Most of these params are not required. These two are. This buffer parameter is very important. Typically, we have, since it is a vector format, we have this numenvs thing in here. You can specify the number of C environments inside of this one Python environment. Not required, but we recommend it. You get your observation and action spaces. This is the same as Gymnasium, pretty much. In fact, we're using the Gymnasium spaces directly here. We set a couple additional things: rendering information, num agents, a couple of required properties. And now this here, this is very important to not mess up. So you need to pass this buffer to init, because the class is going to end up having self.observation, self.action, self.everything. And the reason that PufferLib has this is because it allows us to use big blocks of shared memory. So this little chunk here is kind of annoying, but this is what lets us do all our perf optimizations under the hood for you. And now here, I'm simply going to loop over all the different environments that I want to create. I'm going to init a C environment here, and I append it to a list. And if you actually look at what each of these CMs is, it's just going to be a number. It's just a pointer. Python doesn't have pointers, but it's an address. It's used by C. You see I give it a slice here of the observations. This is the slice of observations that we're going to fill in, which is just the number of agents times the index of the environment. Same for actions, rewards, terminals, truncations. All these just go into binding. Extra parameters that are environment specific can go here as well. I just append this, and then you call vectorize. And vectorize gives you this single CMs thing that you can now call vector methods on directly. Use working out as a tool to enhance your learning. It's what I do in my spare time. It helps me tremendously mentally. It's a source of discipline. It's a source of, just general health. It's a big part of my life. Research is very uncertain, right? Sometimes the outcome of like a month's worth of work, like really good high quality work where I've put in everything, is going to be that I simply discover that a problem cannot be solved in the way that I was expecting, right? And that can get really demotivating. So it's very nice to have like a constant thing that I put effort into, right? That I can get results. It's a very consistent, stable aspect of my life. All right, so we have vector methods here. These are the same as you'd expect from the normal Gymnasium API, normal RL APIs. They operate over a bunch of environments and they're hooking into C. Here we are going to reset all the M's. You can pass it a seed as well. It returns observations and an empty list for infos. Step method takes in actions. You notice here that the way that we're passing actions is actually by setting the actions buffer, because everything is done through shared buffers. You call step on the environments, and then every so often we will go check for logs and collect those. And other than that, you return the standard RL signature observations for boards, terminals, truncations, infos. Same for render, same for close. Little speed test here. We make a whole bunch of environments. We pre-allocate some actions, and then we step the environments. And if I do this, let's see how fast target is. This is not based on cognition papers, Freddy. This is pure empirical science. 34 million steps per second. So very, very fast environment, right? That's on one core as well. So where's the magic happen for this? Well, there's one additional thing that we have to go through here, which is the binding file, which is the glue that's going to put the Python and the C together. It's very short. You simply define the environment name, you include the .h file, and then you include this env binding file. This env binding file is what takes your single environment and makes a bunch of copies for it and runs loops over them. You define an init method here. This init takes any arguments that you would like to pass to your environment. It simply sets the property of the environment to the value from this parameter using this unpack helper. And then the exact same thing with logging. Anything that you want to smuggle out of the environment to put into logs, you put here. And that's all you have to do for bindings. And, if you use our binding system, it's nice and easy. Now, all the logic for this environment is inside the .h. 233 lines, including white space and everything. We've got some standard includes. Well, these are per environment. The only thing that we do regular is we use raylib for rendering. Raylib is awesome. You'd be batshit insane to use anything else. It's that good. First standard component for PufferMs, a log struct. This struct must exist. It must be called logs. It must have this float n field as the last field in the struct. And we suggest that you put in perf score, return, and length. These are recommended but not required. And these are going to be where we aggregate all of the performance metrics for your environment. I have a little struct for the client here that contains a couple textures. Not standard, not required. And then I also have the struct here for the agent. Not standard, not required. You can do whatever you want here. Same for goal. Not standard, not required. Now, here we have the required standard struct that holds your environment. Your environment is going to be a struct. It's C. You don't have classes. You have structs. So the environment will have a struct with an appropriate name. It's got to have a log. Struct has to have a log field like this. And then struct has to have observations, actions, rewards, and terminals. The data types of these you need to be very careful with that they match the Python, but they can vary. So observations do not have to be floats. There will often be like unsigned chars or something in order to save on space. It just has to match the data type that you've declared in the observation space. Same thing with actions. Actions can be int for discrete, or they can actually be float for continuous. Rewards are always going to be floats. Terminals are always going to be unsigned chars. We don't currently actually support truncated, even though it's technically in the API. Other properties that you would like, you can set up here. Generally, we recommend you have some sort of init method. This can get called from that my shared thing from before, from your custom constructor. You see right here that I call this init. That's your init method here in case you need to do any additional allocation of memory. We highly suggest not allocating memory outside of this initial setup. Let me answer this quick question from chat. Training robots to perform a specific task in robotics is incredibly time-consuming. PufferLib be used to suit a robot training? Absolutely. So gosh, the only thing is that I am not deeply embedded in robotics. You absolutely can use PufferLib for this, and PufferLib is very good for RL generally. I've not taken the time to like chuck it at standard robotics M's or sims or frameworks and speed optimize really, but it is a thing you can do. And we have a few people in the community who have done that as well already. Here we have some logic for the environment. So the cool thing about writing your environments in C is you can just write arbitrary code. It's not like a framework, right? It's not like you're writing a JAX environment where you have to express everything in terms of very specific operations. You just write arbitrary code. So here, this is goal setting code. Look, I can write a double for loop, and it's fast because C is fast, and you're allowed to write loops. And then the logic is actually really simple for this piece of the code because that's all I do. You'll notice a couple things here. So this is the, where is it? We've got some logging aggregation here. So every time the puffer gets a star, it gets a point. So we increase score, we increase episode length, we update all our log metrics. And then we also increment this n. Incrementing this n is very important because this needs to contain the number of log elements, usually the number of trajectories. Okay, we have our compute observations code. So similarly, we just write arbitrary loops. So in this case, the observation, each agent gets an obs. Each agent has the same obs. Here's the agent. You go through all of the goals, right? You go through all the different goals and you give it the position, the delta position, normalized delta position to each goal. You go through all the other agents. You give it the normalized delta position to each agent. You give it its normalized heading, reward, width, and the height of the environment. And that is your observation function. Nice, short, and simple. You can view the code for this project. I will put it in the chat so you can follow along. Target. For some reason, my chat does not want to load. Let me go open up the YouTube. It's probably going to not let me link that, right? In the chat. Yeah, it's going to eat that message. Hang on. Oops. Surely it lets me link in my own chat, right? Yeah, there we go. It lets me link in my own chat. There's your link. Okay. So that's the compute observations function. Resetting environment. We simply randomize the agent's position. We like to domain randomize whenever we can. We set a couple other properties. We randomize the goals. We call the compute observations. That's it. With a couple helpers like clipping. Hey, Nicholas, when's your next rep? I am super burnt from all the exercise yesterday, but I'm probably going to start some shoulder work after this little demo. Okay, here is C-step. This is the required step function. So for multi-agent, you see we go over all the different agents. We always zero out the reward. This is very important that you remember to zero out buffers. This does not get done for you. And then the agent, this agent, we update this ticks. We update the positions, headings, speed, so we just do the basic physics here, if you can really call it physics. And then once in a while, just to make sure that we don't get all the agents stuck, we randomly reset them. Or we randomly move them around. And we call update goals, we call compute observations, that is it. That is all the logic for this environment. Now, you'd also like to be able to render this environment, and you have one screen worth of rendering code to do that. So, if there isn't a client, we make a client. We load in a couple of textures, standard escape. PufferLib has this begin drawing command that you do everything inside of. You clear the background, and then we just draw textures for all the goals, and then we draw textures for all the puffers, and we flip them based on the direction that they're traveling in. That's it. And then close freeze all of the data so that you do not leak memory. Lo and behold, everybody says, oh, see, memory management. Well, it's not that hard. That's all it is. Code is in the .h file. Why is that? Good question. So it is in the .h file because this gets included from Python. This is kind of like having a header-only library, Nick, if you will. But the thing that actually gets included in Python is this binding.c. And this binding.c takes the source code from your .h, and it also takes the source code from our general purpose binding glue file here, and it merges these two together. And then the .c, there actually is a .c file. I'll show you the .c file. One screen. This is the .c file, and the purpose of this .c file is actually only for development. So if I do scripts build ocean, target, and I do local, this is a debug build. So this will give me address sanitizer, all that, all the type of stuff you'd want for development, so you're not constantly going back and forth through Python while you're building your environment. And then when I run /target, this is not running Python at all. This is only running the C build. So how are the puffers doing all this stuff if they're running the C build, right? How do they have a neural network? Well, you don't have to do this, but because we like to show off and because we like to put stuff on our website, I wrote a little miniature version of PyTorch in C. And you can load in trained weights into this. We have some pre-trained weights right here. And then there's this little extra call here where we are running the neural net in pure C so that we can have this nice demo. But you don't have to have this neural net in. You can just use random actions for development. And this is already a great way to debug your code. Use Vim? How to learn that fast? It's very simple. The thing is, you only need to know 10 shortcuts, not even, before it's faster than your standard editor. Do you run it in WebAssembly? Yes, I do. So I showed you this running locally, but if I go to PufferOcean, here's target running in WebAssembly. there's no additional code for this, right? This is just compiled to WASM, and now you have the demo running on the website. So this is another perk of this, right? You get your nice local version, you can compile the WebAssembly. And you get to share all your demos. And that truly is everything that is associated with this. This whole tutorial, when I went to write this thing, I think it took me maybe three to 4 hours from deciding I want to make this environment to having built the environment, having trained agents and tested it, and having this thing ready to go. And now this thing like runs tens of millions of steps per second. It trains at millions of steps per second. And now you can just do reinforcement learning really fast. So, for folks watching, the idea of this, if you got here partway through, is I have a lab that has asked me to do a little environment tutorial for them on how to build environments. And I thought I'd take the opportunity to do it live, so that if anybody has questions or things are not clear, you can ask me here now, and then I will use that to improve upon both that thing for the lab on Wednesday, but also for the teaching materials for PufferLib in general. So, we have plenty of folks on YouTube that there should be at least a couple people with questions in the chat. Why don't you all think about if there's anything that you want to ask while I go do my first set of shoulder presses. Is it impossible to make a Python library run this fast? Yes. You're not going to get Python to run this fast. So, aside from it being interpreted, let me just show you the junk. Have you ever seen the Python C API? This is what everything looks like in the Python C API. It's like get item, type checks. It's like there's this huge amount of extra garbage on top of every single operation. And there's a garbage collector. Not to mention it's interpreted. It's fundamentally a very slow language. You can go check for yourself, just like write some basic loop in Python and then write the same thing in C. You'll see it's like at least 100x faster in C. Like, oftentimes people underestimate how slow Python is compared to C, believe it or not. Presumably that's, have you tried Mojo? No, and I saw a few things about the language I really didn't like, for starters. But then also, like, there's just no point in trying to do all your whole big open source project in, like, some esoteric language that nobody uses. What's the difference between writing your env here and in petting zoo? Sure, so you can use PufferLib with the petting zoo environment, but you have to do this. Petting zoo is actually a terrible library for performance reasons. Where is it? So we have this emulation thing for working with petting zoo environments and gymnasium environments. This is just applied on top of your env to make it compatible with Puffer. Let me see if I can find you the problem. It's kind of this stuff down here. Get you a better version of this. Yeah, so the problem with petting zoo is that the observation, it's a dictionary format, and dictionaries are slow. Like, literally, if you were to just do the dictionary operations of, like, packing and unpacking observations in Python, not even running the neural nets, you'd be slower than PufferLib. So, petting zoo has this dictionary format. PufferLib has a vector format. So PufferLib is kind of like a gymnasium vector env, which you can do that for multi-agent and single agent in the same API, and it's fast. Whereas petting zoo is this really flexible thing, but nobody actually uses all of its features, and that flexible thing makes it unusably slow. Like, you actually just can't use it. So this is the puffer env environment. By the way, this is the entire puffer env code. Like, it's just a spec. There's nothing to it, right? And all this thing has is a few checks to prevent you from shooting yourself in the foot too badly, and then this set buffers command. And all this set buffers command does is, like, if you don't give it a buffer, it allocates a bunch of memory for you to write all your observations in without having to, like, keep allocating memory over and over again. And otherwise, it just sets it to whatever you give it. And that's the entire thing that the puffer env does. Now, the cool thing about this, right, is that this buffer here, I can actually pass in a slice of shared memory to this, and then PufferLib runs everything entirely in shared memory. So it's not that it's incredibly complicated, but this is just such a fundamentally higher performance design. It's not even close. So to make an env, you have to know C basically. Yeah, you can run emulation on it. So here, what are some examples of this? We have a couple in PufferLib somewhere, but I have it on the docs page. Here, wrapping a multi-agent petting zoo environment. So here's a petting zoo environment, right? Parallel env. You literally just call PufferLib emulation petting zoo puffer env, and now you can use it. But it doesn't magically make it faster than the original env, right? So you're still limited by the petting zoo API when you do this. PufferLib can make the other portions fast, but it can't make your env as fast as if it were a native C. But I mean, if you saw my native C, right, this is not hard. Literally, this is simpler code than you will be given in your assignments in your first systems course as a freshman in undergrad. This is really, really simple code. And the crazy thing is how well this scales. If you actually take the time, I'm not going to go through it all now, but if you just take the time to read through Neural MMO 3, which is the most complicated env in PufferLib and arguably one of the most complicated RL environments out there in use in research, yeah, it's longer, it's 3,000 lines, but guess what? This is a third of the amount of code that Neural MMO 2 had, and Neural MMO 2 was in Python, and this thing is at least 500 times faster than Neural MMO 2, and if you actually read it, it's really basic stuff. This is literally just if statements and for loops all the way down. Just really simple loops and branching logic, no abstraction, top to bottom, how you write a game in the simplest way possible. I would argue that doing this is way more accessible than trying to teach somebody how to build a project of this scale in a language like Python and then not having it be unusably slow because of speed. Because trying to get an actually even remotely usable amount of speed out of Python is way harder than just writing really naive C. And the only other option you have, I'm going to just go to a random line number here. I'm going to go to a random line number. All right, this is what the code looks like. The only other option is JAX. I'm just going to go to a random line number in JAX. You can see it's literally all right. This is a wrapper. Where's the actual env code? It's already more complicated than my thing. Nope, not this. Where the heck is the logic? Oh, there. Okay, so if I just jump to a random line in here, which of these is simpler? So Neural MMO is faster than CraftX by an order of magnitude for pretty similar game dynamics. Actually, ours may be even a little more complicated. Which is more simpler? Which is simpler? I have basic loops, or I have literally JAX calls to even do a frickin' OR. Everything is array operations. Which of these would you rather have to write? So that's the only other option. And mine's still faster. Do you support parameter sharing and independent networks? Parameter sharing is by default. You'd have to write just a network wrapper if you wanted to do independent nets. We kind of just do everything with shared params by default. But again, so if you want to look at the complexity of hacking on stuff with PufferLib, this is our trainer file. So our entire trainer is 1,200 lines, and that's including like our dashboard, that's including hyperparameter integrations and everything. So it's just this one file is the training algorithm. So you're free to mess with this all you want, right? And actually, the real training code of this ends right here. It's really only the first 500 lines is the real training code. And then the rest of this is like checkpointing, and then the dashboard, and then like all these extra like profiling stuff and utilization, yada yada. So it's maybe like twice the complexity of CleanRL for over 100 times the performance, and still way less than the complexity of even something like SB3. Would Jax code scale? I thought it to run on GPU or TPU and would win at some point. Well, no, because if you have 8 GPUs on your machine and you're running your environment at 100,000 steps per second per GPU, which is what it runs at, then you have 800,000 steps per second. And that leaves you nothing left over to run the neural nets. Whereas neural MMO will run over 800,000 steps per second on one CPU core. And if you have a machine that has some GPUs on it, that machine also has some CPU cores on it. So you get to run your env at 1.5 million steps per second, and you still have all your GPU capacity free. So presumably, right, when you have an 8 GPU node, you're going to have at least 32 cores. So you've got at least 4 or 6 cores per GPU as well. So it really doesn't even scale any better necessarily. How long does it take someone with no RL experience to get caught up on PufferLib? If you have reasonable eng experience and have done any amount, literally any amount of low-level dev at all, you'll be able to build a new environment to play with in a weekend or less. For building like reasonably complex stuff, give it a couple weeks tops. Yep, environment runs on CPU, agent runs on GPU, Nick. Oh, and by the way, I actually am thinking we're going to do GPU environments pretty soon, for the heck of it. Do you know how easy that's going to be? I'm basically going to just copy and paste the code into a CUDA kernel, and it's going to run on GPU. There's like a little bit of refactoring I have to do, but not that much, because CUDA is basically just C that runs on GPU. And if you want to parallelize naively, you can just literally put one environment on each CUDA core. So even if you want to do stuff on GPU, I still wouldn't do Jax. I thought it would have been more involved. Here's some CUDA code. We have our advantage kernel. This is the PufferLib CUDA. All right, this is our advantage kernel. And if we just ignore the 2 tags right here, this is literally C. So your CUDA code is literally just C. Right? And then actually, it gets called right here. So this is the CUDA kernel itself. All you have to do is squint and ignore the fact that you get this extra block IDX thing that specifies the row, and then this little global tag, and then this is also C. So literally, you're just doing C. First E to C textbook. I've never read a C textbook. I wrote Python for 10 years. It's just not as hard as you think. Do you know what a pointer is? Do you know what malloc does? Cool. You know enough C. No point in learning to code anymore because AI can do everything. Can't sleep at night. Yeah, so those people are assholes. Fuck those people. Go learn to build stuff. Those people are like stupid and worthless. Go learn things and go build cool stuff. And stop scrolling your X feed so much. It'll drive you crazy. I mean, AI is kind of worthless in my day-to-day for the most part, so no, it's being massively over-exaggerated how good this stuff is, because woe and behold, companies are making billions of dollars by over-exaggerating how good their stuff is. How long does it take to learn C to build an env? It depends, Nicholas. Did you ever see any amount of low-level programming, even like in like a random intro undergrad course? Or do you like or do you not know what a pointer is? All I know is Python. Okay, whoever the heck taught you, like wherever you learned the programming, that is criminal that they don't teach you any low-level dev at all. You have a little bit of learning to do. You probably are going to have to watch like maybe a handful of systems lectures on YouTube, but like it's probably a few hours of content at most. You pretty much just have to understand that like Python is not actually how your computer works, right? Like Python is a very high level language, and you need to understand at least a little bit about how your computer works, right? Like the stuff that you have actually corresponds to addresses in memory that are written in bytes, contiguous or non-contiguous. You actually have to allocate a chunk of memory to write your bytes into. But like once you understand the very, very basics of this, then it really doesn't take very long. Like I honestly think that you could be comfortable with this stuff in like a couple weeks. Yeah, seriously, gosh. It's like I really, really hate the people that are like, oh, like, yes, actually, have this awesome new technology, right? We have like these awesome innovations in AI, but I can't think of how that's going to make the world better in any way because I'm an idiot. So I'm just going to go around saying, oh, actually, nobody needs to learn to think anymore. The AI is just going to think for us, and you're not going to have jobs, and life's going to be awful. I hate those people. CS50 on YouTube. Is that MIT or Harvard? I will say don't watch the Stanford Systems courses. The Stanford Systems courses were so bad. I took them in person. They were so bad that they put me off of systems dev for a decade. I don't think I can give a like I don't think it's possible for me to give a more damning review of the Stanford Systems core than that. It was awful. And like I hated my lecturers so much as well that I literally thought that systems programmers were just assholes and losers for a decade as well. It was that bad. Harvard? Do Harvard students actually know how to code at all? Probably the MIT lecturers are up somewhere, right? What would be your guide to learn C then? I mean, you can literally look this stuff up. Like, it's not that much material is the thing. I actually don't. You know, I actually need to. I should go ask some people in the Puffer Discord if they have a favorite resource for this. I'm not really big on courses unless they're extremely well taught. Um, and you really don't need a whole course on C either, like for learning the basics of stuff. Uh, so Nick, that works for the most basic stuff possible. I've actually had very bad results trying to use language models to learn anything other than the standard basics of a thing, though. Welcome, Alien. Do folks have any other questions, though, on the little env tutorial I went through? Because if not, I'm kind of feeling better, and I don't think I have any replies. Yeah, I don't have any replies yet on this meta stuff, so I could do the dashboard. There are a whole bunch of different things I can do at the moment that would be interesting. You're right about that, Nick. You can at least just ask a language model what a pointer is and shit. Probably give you a decent one. David Milan. Is that CS50? If it's decent, then sure. Actually, the intro, so the very, very intro Stanford course wasn't awful, I guess. It was pretty bad, though. CS 107 is the Stanford one. It wasn't awful, but it really wasn't good either. I mean, honestly, what happened with me is I like saw that material when I was 18, right? And then I went and I did research in science and I wrote Python for a decade. And then I actually cared about trying to get better as an engineer the entire time. I just didn't realize how much I was screwing myself by just writing Python. And then I started writing C, and within a couple of weeks, I was just totally comfortable with it, right? Like, it wasn't that big of a shift for me because it just made sense having written code for that long, you know? There were, like, only a couple things I remember being really annoying to get used to. Like, the things getting passed by value by default, that was really annoying to get used to. And now it's just whatever. Oh, the other big complaint I have about a lot of these courses is they give you starter code for shit, right? Like, they give you this big block of starter code for your assignments, and they have you fill in little snippets of stuff relating to your lectures, and that is not a good way to learn to program. Like, a good way to learn to program is like, hey, go build Pong, right? Like, go build me a Pong game. You'll be graded on how good it is. Go do it. No starter code. Hint, use Raylib for rendering. Don't use anything else. That's a good assignment. Okay, I'm trying to think what I want to do now. So, there are a few different ways we could go at the moment. We have the... Let me go check my email real quick first, off screen. So I'm not missing any client obligations. Doesn't look like I have anything. Cool. BRB building Pong. I mean, but the funny thing is how it's like it's such a small shift from building Pong now to having RL that also plays Pong for you, right? Like, this was not a thing before, but this just works now. And it literally, the RL for this trains in 3 seconds. 3 seconds. I'm trying to think if I just want to do a little work on the dashboard today. That's probably the most chill thing to do, right? Is just do a little bit of work on the dashboard. Maybe we have some new people in here who haven't seen this, but this has been my latest project. This whole thing is in C. High performance visualizations for large quantities of RL experiments. I built pretty much all of this over the weekend on stream. Oh, this is the wrong version of it though, isn't it? There we go. Looks a little better. What do we have left to do on this realistically? So, in order to finish this project, UI styling, we have to fix tick layout clean up code. Oh yeah, there's like this. There's one more feature. Secret feature. Color scheme for points. And then possibly a cool shader. And that's pretty much it. Get some inspiration from the website. Let's try a couple different color schemes. The points. We'll just do some chill stuff for a bit. Because I have to do it anyways. And when I do like a really long and hard work day where I'm like, because it's not just like, oh, I get up in the morning, I think I'm going to work 12 hours, like 12 straight hours of stream today, right? I kind of prep that stuff. Like, I kind of arrange everything around just, like, being fully focused that day. So it really feels like I kind of burn myself out quite a bit doing that. But I end up getting, like, a week's worth of work done in one session when I do. So, kind of still feeling a little bit tired from that. What kind of food do I eat with that work and exercise regime? Um, just generally like variety of relatively healthy stuff. Mostly like just some amount of vegetable, not a ton. Like balanced enough. I don't know. What do you call that? I have a protein shake every day at the least that has enough in it. Um, I'm having meat with, well, seriously, meat with every meal. I'm having protein with every meal at least. I guess breakfast these days I'm just having a protein shake with. But generally like a good sized chunk of meat for dinner. I typically only eat 2 meals a day. I ate a third meal yesterday because I was literally just lifting weights all day. The only thing that I have to do that's different from most people is I have I end up having to have like pretty high calorie density in a lot of my food because I do not have the appetite to eat like 25 to 3,000 calories a day worth of like lean protein and rice and stuff. That's just too much volume of food. So I have like heavy sauces and stuff. I mean, heck, even after the lifting, I got up this morning and I ran my not quite a 10K. It's like 5.7 miles is the loop I have around here. Ooh. The problem is the dark shades, right? You really can't see with the dark shades. You really only get like two or three. Yeah, I can't actually tell these apart at all, right? So it's a cool two-color scheme, but like you can't really just do shades when you have this many different points. And I tried the divergent palette as well, and that didn't work either. Let's see. The problem is how many different... I just have so many different tracks on the same plot, right? Is that... I don't think I'm doing it wrong to be doing it that way, though, right? So this is... Where's my original plot? Alright, so this was the... Oops. This was the original plot. The spinning graph is covered by Cam. Yeah, I'll show it. My bad. But this was the original plot, right? So here, the thing is, I have 12 different tracks, and you can very clearly see them separately, right? Here, you can't see it. And then even if I do... Even if I do this... Oops. Like, you can mostly see it, right? Well, I mean, I can take out a couple of these colors, right? Like the dark brown and the gray. This is already aggregated, man. There's like... This is already aggregated. Is it just me? It looks less clear, right? Because... Is it because it's getting stretched? It looks like less clear. Oh, actually, you know what? It doesn't really look that clear here now that I have this many plots on it either, right? I guess there are, like, some colors that stick out. So each color is a different environment. You're generally trying to just see the shape of the environment curve on this. You know, I should probably just copy-paste this UI here. I should probably just take this UI and put it here, right? Because you can't fit good curves to this stuff, man. It's like there's surfaces, and it's very hard to fit like nice surfaces to this. I tried. Let me see if I just, what happens if I put this UI there, though. I think that much I can handle, right? The heck is wrong with this? Why is everything highlighted? What the fuck? Hello? Okay, I don't know what's wrong with this terminal, but you can go away now. Oh, you think IDEs don't crash randomly for no reason? A news for you, buddy, and maybe a bridge to sell you. Alright, let's just try something. Big 2 has this super obnoxious thing attached to it. Hmm. Yeah, I know. like this. So figure 2 ends up actually having almost identical params. We do no J here, right? Why the heck do I use J? So I know that this is a mess at the moment. Basically what I'm doing here is I'm trying to get the dashboard to look right, and then I'm going to identify the pieces of code that, like, I can duplicate out. Okay. And then we have to copy the buttons. Which should not be... Is it literally identical? 1, 2, 3. It's almost identical. There's one extra button that's not there before, right? Which is the Z. So it's env XYZ color. Still think that that's probably the easiest thing is if we just copy this whole chunk. Stick this. Okay, so between these two, we need this goes to here. Now this needs to be the Z, right? And this is 3. This is 2. Okay, that's good. And this one as well. This is 4, 2, Z. All right. And now all I have to do, this is now, these go up by 1 each. Other 1 each, right? Four and 3. What do I do here? Oh, dummy. Hang on. Yes. X, Y. Wait, X, Y, Z, and color. Perfect, right? This is everything. This... Ah. Kinda cool. This is breakout colored by agent steps, right? That's pretty sweet looking. We can color by env name and do all. We can do like this is 2048 by agent steps. We can also do by like stuff like gamma and see if we see any correlations in there, right? So I can do all of them, but now they're colored by learning rate. Are they colored by learning rate? This seems suspicious. No, that is actually... Is that actually colored by learning rate? Maybe. I don't think it's colored properly exactly, but it's decent enough. There'll be some small fixes to be made. At least we now have a few different things we can do with it, right? How'd you do the color fading? So I drew them with opacity. And if you want to do it the way that I did, there's this one annoying thing you have to do for off-screen buffers. Let me see if I can remember where it is. Yeah, this thing. You have to do this blend mode bullshit. It's actually kind of irritating to have this color palette for stuff like this, right? Well, I guess we may as well just figure out how to clean up a little bit of this mess, and then it'll get easier to make this better. Use the restroom real quick and get another set in. Man, I'm just tired today. Holy. Be right back. Hey Kyung, non-sweep related PR. Let me look. Which one? 334? Oh, okay, this is a while ago. Let's see. Okay. Wait. Are you sure this is right? Oh, okay, this got moved up to here. I thought this was a config PR. There's a bunch of stuff in here, some of which seems a little sketchy. But this looks like it deleted the train copy measurement entirely, no? Okay, here's the actual PR. Hmm. Wait, what? I'm trying to see what this even does. This is kind of a messy PR. Different file not under the default directory. Yeah, and that would be useful. I want to add custom tags. I would like that feature, Kyung. Can you clean this up, though? Like, I can't tell. It seems like there are now multiple functions. You should basically just be able to have it look in the... It should just be able to also look in the current directory, right? Like, wait, why is there so much stuff around this? Shouldn't it just be like an additional check to look in the current directory, not just the puffer config dir? This user account need what? I have no idea what that question is. Yeah, sure, Discord, Young. I can do that. I have no idea what that question is. Oh, yeah, sure, Discord. Why am I listening to my own voice here now? I'm listening to my own voice from somewhere. There.
Hey,
Hey, Kyung.
hey Joseph.
How's it going? Long time no see. Kind of long time no see.
Yeah.
I've just been building all this crazy new stuff. Have you seen the new you've seen the new visualizer?
Yeah, just seen from the screen. It looks cool.
I mean, all
Yeah,
sorts of
like
crazy
I
stuff.
said, you are making like 1 dB obsolete.
I like to be the shock cavalry of RL. It's fun.
I know. Yeah.
So I'm
So
way behind on
yeah.
merging stuff. Like I've basically gotten stuck into research and I've gotten way behind on merging and not just like fixes but also new environments and all sorts of stuff. But I'm happy to get this config thing merged in as long as it's not going to cause me like a bunch of problems from a broken build that I figure out like that I learn has been broken in 2 weeks. Um
Uh, yeah. So basically, like it this will make the current workflow uh work as is. So like so
like how
so the
there's a first of all there's a ton of stuff in here where
mhm.
like it like unrelated to config that I'm sketched about because it looks like this deletes the train misc profiling or no the train copy profiling completely.
No,
Eh,
it does not. I add another one right there. So
oh
I
wait, okay,
moved the
I'm dumb. I
copy
see
of
it.
it.
But wait,
Hmm
was there
I
no
I
train copy right here? This is deleted. Oh no,
so
it's here.
no, it's copied. I just put the
Huh.
nest flag up there
Okay.
because that nesting somehow like my MISC profile got like added up and somehow.
Hmm.
So yeah, once there's a
Okay.
more mini batch, it gets nested, right? So
All right, let me see everything here. Because I think you have a bunch of changes in here, some of which are actually fine. So this is just example. This is fine.
example that I there like I'm loading config and like trying to like set
Mhm.
other things and like passing it to making end-to-end policy.
Yeah, this
That I
I
took
think
it
it's because
from
it
like
breaks
Debbie.
compile, man. I think
Hmm,
this breaks torch compile.
I see. So like yeah, those stuff stole from David's PR, like which also he has made like a proper core, but yeah,
Yeah, but
I'm
David breaks
yeah,
stuff all the time too.
I see. So like since I'm not like testing compile, so yeah, I will like
Yep.
have those back. Mhm.
I'm
Yeah,
pretty
that
sure
that
this breaks compile. Um
okay. Yeah.
compute puppet. So yeah, this is everybody's asked me about this thing. Um so basically I'm pretty sure this was an error, like the fact that I had this, but I didn't change this because this could change algo performance, and I didn't run training on like a bunch of M's before and after. I guess I can technically keep this. I can keep your PR in, and it's probably fine because people have been asking about it. It's not exactly good science, but sure. Um,
Right after you are just changing
I
it, right?
realized
So
so that
unless
was a bug, right? The fact like that was a bug, but then when I wrote 3.0 and I did all the benchmarks for 3.0, I had that bug in
mhm.
there. So like ideally I'd want to go rerun everything. So I didn't want to like push something that could change algorithm performance, right, without rerunning a bunch of tests. It's probably fine. So I can leave it. It's like it's probably fine, but that's why I didn't do that change before. Um,
Yeah, I know, but now you are going to run another like sweep.
yeah, I'm gonna
So
run more
yeah,
sweep, but it's gonna take me like at least a couple months, if not more, for Puffer 4, right? Where I'm gonna do all the new stuff.
yeah, I know, and that's why I'm also looking at like sweep itself, like trying to make it like faster. Like,
So I
but
have
that's a
one thing that
different
does make
story.
it faster as well. I have in the multi-sweep branch, I have it so that you get like 5 suggestions at a time or whatever instead of just one. Um,
Hmm.
but I think that there are additional perf changes I'm going to want to merge in as well. Perf is
But
actually a big thing
oh,
in
okay.
the new puffer as well. Like there's going to be a big chunk of time I'm allocating to perf. I think we can get puffer well over 20 million steps per second. Honestly, I
Yes,
think I could make
still,
a fun demo
yeah,
that gets to 100 mil.
that'll be awesome. I mean, like just testing stuff got much easier with the ocean. Yeah, so that's
Yep,
kudos to you.
I'm trying. It's a lot like I did this whole thing. So this is all. You see what I'm trying to do? This is 2,500 Pareto experiments taken from 40,000 total experiments.
Uh-huh.
So I'm trying to do like the largest scale experimental visualization and analysis ever in RL.
Yep.
And like obviously you can't do this in 1B.
Yeah, that's true. That looks so cool. Anyway, yeah, you're coming back to config.
Yeah, I'm
So
looking at
so
it.
what
So
what
why
current
are there
config?
multiple functions? Like why
Yeah,
did so
so
much
what
stuff change is my question. Why is this not like why is this not as simple as just adding like this additional directory, which is your user local directory here?
uh no, it's default. It's I copied so that part uh so what road config does right now is it merges the environment specific INI with the default,
Mm-hmm.
right? And also and then it it makes the parser too, right? And then that parser process like all the configs, right?
Yeah, so that you
So
get CLI args.
yeah, so there like I broke that by allowing so the config processing is handled by those process config, and like I also made that load config file so that either the config sits in the default directory or you can provide the custom config file separately, and then and then it does the similar thing as above. So
All right, well,
yeah, so
I guess you know what I'll do for you. I'll just merge it. I like the feature. I might want to have the code be a bit more compressed, but I like the feature, so I guess I'll just merge it. And
yeah, yeah, like I mean, config system in Puffer is I've been through it like 3 or 4 times, right?
yeah, well, I mean, I want to. The thing is, eventually, I want to have my whole train file and everything. I want it to be faster than it is now and under 1,000 lines.
Yeah, but yeah, that's the best I could do so far.
That's
But
fine.
yeah,
We'll just merge this here. Let me go grab the browser that's actually logged in.
and like sweep related, the let's see what's its name. So I'm working with like someone from Discord, Puffer Discord.
Test before merge, please. Convert. I test before I push a new pip package. Does that count? Discord
Huh?
is a thread with a sweep experiment 23K. Is there a PR for the new sweep changes as well that you've been working on or not yet?
Not yet. Like
Oh,
sweep requires much more like a test,
yes.
right? So
Yes. That one is essential as well. So I'm actively doing stuff with this now, right? With all this Have you seen the multi-sweep stuff?
No.
So I have multi-GPU sweeps, and I've been using them. I've already run like 40,000 experiments on these.
Mhm.
Where is it? It's just in PufferL right now. All right, so there's the original sweep, but now there are two others. There's Pareto sweep, and there's multi-sweep. So multi-sweep just does, let's say you have 6 GPUs. It'll use all 6
Mhm.
GPUs for the same sweep. So like 1 GPU per job, and it'll just queue up new jobs on GPUs as they're available. And then Pareto sweep runs 6 different sweeps. It just runs 6 different sweeps with different numbers of total time steps. So you can get like evaluate sweeps at different number of samples.
So one hyperparameter, but like a different number of. Oh, okay.
Yeah. So I mean this is messy and like obviously can get combined, but for dev, this is what I've been using to run. So these experiments here, these points, these are only the Pareto optimal points from 12 different environments. Each of these 12 environments has at least 1,200 experiments. So, and then some of them have way more than that. So this is like 30, 40,000 experiments worth of data here, compressed into 2,500 Pareto optimal points. And now I have
Mhm.
all sorts of visuals on just the Pareto points.
Yeah. So
This is all done with multi-sweep or Pareto sweep, these two.
okay. So that's still using a Pyro, right? So like
Hmm?
one thing I noticed with
Pyro?
yeah,
Oh, Pyro.
yeah, the
P or
current
T?
the PYRO, the Gaussian you
Yes,
use for
yes.
Gaussian process
Do you have
regression,
a
right?
replacement for that thing? I hate that library, but I don't have a replacement for
Yeah.
it.
So the one thing we've been testing with Jerov at Buffer Discord is that I think GPyTorch is faster, and
Okay.
Pyro does for each regression, like it does like 1,000 iterations, and you
Yeah.
don't need 1,000 iterations. It's like
Yeah.
I'm looking at like 50, 100 or so with different running rate. So yeah. So we are kind of like doing that.
Okay. I mean, that would
uh,
be great. So the one thing I do have here is I added this buffer size,
mhm.
and when you suggest, it actually goes and it suggests you. Where is it? It suggests 5, like the top 5 suggestions.
Mhm.
And then what happens is in PufferLib, uh, so in PufferLib, when I need to get a new suggestion, PufferLib, PufferL. This is kind of cool. It's kind of cool, kind of a hack, I guess. But in multi-sweep here, when I need to get a new suggestion,
Mhm.
well, I think it even just does it for you. Hang on. Yeah, wait, I forgot. I literally have it do it for you. Sweep suggest. Yeah, so it just gets something from the buffer if there's anything there. So like it'll just retrain every 5 or whatever. Now, I think your thing is better, where it should just do a very short optimization every single time. Um, I
It's
actually,
default. Yeah.
yeah, I actually think that this needs to be way, way faster though, because like, I
Yeah.
think that,
So
yeah,
that's what Jerov initially discovered. Like when you are doing sweep on like a breakout and so forth, just getting those like hyperparameters
yeah, it takes
are
forever.
taking
It takes
one
most of the
third
time. It's horrible,
or
right?
yeah, like I'm trying to cut that down uh, while having like similar performance. Like
Yes.
so, GPyTorch with like some good hyperparameters will do that initially,
Hmm.
and like and there are like several points to make it better, like plus multi-sweep, but like let's get like step by step. So like trying to replace Pyro with GPyTorch with some good hyperparameters seems to be
G
like a
PyTorch.
good next step. Yeah, GPyTorch. So like
Oh, cool.
you are in the discussion here too. I will just like
Yeah, I saw it on the
mentioning
Discord. I
this.
just have not been keeping up with a lot of this stuff. I've just been kind of
I know,
cranking on dev.
but that's where like Zerov and I'm kind of like sharing results. So
Hmm.
yeah, once like we are confident that like GPyTorch is comparable and faster, then that's a like a easy win, right?
If it's compatible and faster, it's an easy win.
So yeah, let's start with that. So.
Yeah, that'll be good. And I actually we're going to need this even more in the next update because if I do get training to be 100 million steps a second, then like we absolutely can't be waiting for sweeps, right?
Yeah,
I
that I
actually think I'm
figured.
going to be able to
And
do it. I'm not even joking. Like I think I'm going to be able to do it.
I know, yeah, sweep is huge in your workflow and everyone else. And
Hmm.
sweep itself is also interesting. So it's a good problem.
Sweep is a very, very important problem, actually. It's just a hard problem. I fought with so many things with Protean, and it's still like I
Mhm.
think it can still be way better. That's
Yeah,
like one of the
I
bigger
agree.
science side projects that I would love to just give to somebody. But it's one of the harder things where there are not that many people in Puffer that have the ability to do this type of work.
Yeah, so I think we started. So let's see where it can take
Yeah,
us.
I think definitely to start, just if you make it faster, that's already good. If you do make it faster, actually, it gets easier to start doing the algorithm ablations, right? Because like let's say that we
Yeah.
get Pong down to the point where you can run a whole sweep of Pong in an hour or less, like a 200
Mhm.
run of Pong, then actually you can probably compare different hyperparameter tuning variations on Pong or Breakout, right? And I'll spot
Yeah,
you some GPUs
of
for that
course.
as well. Oh, I got a question. Do you ever plan to add SAC to PufferL? You would have to convince me that it's not useless. Every time I've tried it, it's just like super, super slow and it doesn't scale well with more data. So yeah, it's technically can be better sometimes if you don't have much data, but it's not like even that good even in that case, and it's always slow. So I've not had a good time with that. I think it's just a bad algorithm. And it's like roboticists have kind of overtuned to that so that they use it by default a lot of
But
the time.
still, like once you start to work with real robots and real world like RL, then
I
yeah,
will
I have
make bigger
to like
sims for you.
tune into sample efficiency. So
But it's not even good for
one less
it's not
than
even
try.
that good for sample efficiency, right? Like it's really not even that good for sample efficiency. Like then you start to get to the model based stuff where things are really obnoxious to make work, but like way more sample efficient, right?
Yeah, okay. But yeah, I'm like studying on that side too. But yeah, let's start with three. Yeah,
Yeah.
GPython.
Well, the sweep stuff I know actually can be made to work and will be useful, right? The off pol. Did you
Yeah.
read the Bootstrap article?
Yours?
Yeah.
I think
YRL
so.
failed to
Yeah.
bootstrap.
Mhm.
So I mean that's like that basically had all of my thoughts in it, right? This had all of my thoughts on off pol versus on pol versus everything and like fundamental differences.
Uh, yeah. So that's like where I start to look into Popperare and Breatrace, and the beauty of Breatrace is it actually it somehow nicely combines on policy and off policy, right?
I don't think it actually works very well though is the thing. Cuz you can set
Huh.
Puffer to just do vtrace without GAE and it's really bad.
Mm-hmm.
Like
Hmm.
I think and it's in this article as well cuz vtrace just does importance sampling and all importance sampling does is not use your old data. Like it just
Hmm.
like smooths out and uses your old data less, which is not what you want. You want something that can use your old data effectively. But I think basically that
Hmm.
just most of these like semi off pol methods are just bad.
Hmm. Okay, but yeah. So okay,
I will
a
tell you
lot
the
of
latest
stuff
thing,
to do.
Kyung. I actually have
Uh-huh.
something that I do think will work, but it requires simulator side work, which is
Uh,
state sets. If you build your sims with state sets and you want to do Go Explore style stuff work, that will actually work because you can reuse states instead of reusing samples. So you can get pure on policy fast data.
what states that?
So like being able to set the state of your simulator, the Go Explore.
Mm, I'll have to look
Look
into
at that.
those
I think
rules
that
first.
that
Yeah.
I'm not ready to do this type of work just yet because I have stuff to do enough for Puffer 4, but I
Hmm.
suspect that that is actually going to end up being the solution.
Mm. Yeah, let me take a look.
Yeah. That's
Yeah,
going to be
the
some
the
eng work
last
though.
word on the abstract is like robotics. So let's
Hmm.
see.
It'll work for robotics too. You just have to build that stuff into your robotics sim.
Mm. Yeah. So okay. And one thing like on the robotics sim side.
Hmm.
So like with the what's that like a Popper PhD, we were using Isaac Gym there, right?
Yeah.
And I think Isaac Gym is finally fading out.
Heh. Yeah.
Yeah, with like a new Isaac lab and Mujoko lab,
Hmm.
and based on like a Mujoko warp and so forth. So yeah, the sim is like, changing. Yeah.
Yeah. I mean, definitely. And well, this the reason I haven't gone heavy into robotics is because it's one of the areas that actually has reasonable amounts of investment. So, like, in order for me to actually really make the sim stuff better, it's not like other areas where I can just sit down in an afternoon and just write something better, which I actually can do half the time here. Like, it would actually take a lot of work in robotics to do this stuff. Um, but I think that you can make a lot of it like much, much better than it is at the moment.
Yeah. So I think like, with the new warp backend, I think robotics can get up to like 200, 300K easily.
Yeah, so that's
Uh,
usable.
so
Yeah, that is usable.
so yeah, like that is that is in sight. So
If you
I
want to
think
bind
Rex
stuff
was
to like if you want to bind stuff to Puffer with this, you can probably crush some benchmarks just because nobody else has access to protein and like tuning and stuff, right?
yeah. So like I was playing with Mujoko playground and like I had to experience some jocks into it. Jocks was so different. but but I hope the like a new Mujoko lab uh is avoiding jocks, so probably it'll like play nice with like PufferLib.
So
Yeah.
I went and ran a perf benchmark on Jax last week just to see if I've been
Mhm.
completely stupid and like if Jax compile is just faster than Torch compile and it's not. Like in my test Torch was faster. Here, let me give you this. I
Mm.
wrote this last week. So I literally don't think there's any reason to care about Jax at all now. Here, I have profile Torch, profile Jax. And it's just a little test. So you're free to go see
Yeah.
whether you can, like, if I've done anything wrong here. But the Torch one was faster than the Jax one. Profile Torch. Oh, but you know what I found out? And this is, I'll tell you, this is the plan for Puffer 4 here. You actually have to compile the whole train loop. That's the thing.
Ah, yeah. Yeah. So hmm, that
So
that's used.
yeah, and actually, so for Puffer to make it like 100 million steps per second, you actually have to compile the environment as well, I believe,
Hmm.
because like the environment is in the
Yeah.
forward pass. So I think what I'm going to do is instead of writing the environments in Jax, I'm going to take like Puffer Pong or whatever. I'm just going to copy paste the code into CUDA, and I'm going to see if I can just get like a full end-to-end compile version of Puffer, and then I'll see, whether that makes a difference.
Sounds cool. Yeah. Now end-to-end compile. Yeah,
Yeah.
that's
But
that's
even when I'm
something.
doing that, I still don't want jacks. Stupid thing.
It was, yeah, so
This is
different. So
bad.
I had hard time understanding it.
It's just bad.
Uh, I would say different to begin with. So, uh, and I think like one thing, like one more PR that is not mine, that like it would be great for you to have a look, and that's like AMD patch. Uh,
This thing work? Where's this? What?
uh, in the PR, like that starts with, yeah, that one, HIP ROCM. Yeah. That looks great. So
I didn't realize you can build. Wait, BUID?
yeah, just leave a comment there, and that like let him know like you are like give him some like review, and like
Well, I can just.
yeah,
Does it
try to
work?
work that into it.
If this works,
Uh,
I'll just
it,
merge it.
uh, I don't- yeah, just I will ask him in Discord right now. So, but yeah, just like getting your attention toward that. So,
Is this a real person, by the way?
ooh, I don't know about elevator guy.
There's some like weird things that I'm not sure. Yeah, it works. Oh, is this? Wait, is this Sosforex in the chat here? QWERTY?
Yeah,
Typo build. Okay, yeah, it works. Cool. If this works, then I can just merge this. Yeah.
actually, yeah, I have to say hi to him.
Thank you very much.
Yeah, he's like doing like sweep work with
Yeah,
me.
my bad.
So
I'm usually better on merging PRs. It's the thing is, I'm just like I get super hooked into a specific new like piece of dev, and then you see like on Saturday I was just literally building this. So I like go and do this stuff for 12 hours, and I burn myself out, and then it takes me a while before I actually get around to doing a whole big batch of PR reviews.
anyway, yeah. So I think that's it for me today, and we will go
Cool.
into the testing sweep.
Hey, I'm looking forward to
Yeah,
the
let's
sweep
get
stuff.
that
The
like
sweep stuff will be
pyro.
really helpful.
Yeah, let's get that ugly pyro out of sight.
Yeah, that'd be good. There are like a bunch of little things about protein that could have potentially been changed or messed with as well. The one big thing that I haven't been able to figure out, Kyung, was you know how there's this downsample arg, right?
Hmm.
So the
Yeah,
idea from that is you'd get like 10 points to represent the train curve instead of just getting the last
yeah.
one.
I thought that was genius.
Yeah,
So.
it's clever, except the thing is if your train curves, like let's say you're running Pong, right?
Mhm.
And you're running like 8,000 M's or whatever, then the train curve is
Uh-huh.
actually going to lag behind a lot because you don't have accurate evals, and it can actually crash your
Hmm.
sweeps if you're only getting an accurate eval at the end.
Hmm.
So
I
there's
see.
like this little
Hmm.
exploit in it basically, and I don't have a good way around that because it seems to me like you really don't want just 1 point per sweep. But like I don't know if there's
Right.
some way that we can do like for experiments that are below a certain length or like some way to determine that.
Yeah, so one way uh I will be testing is another GP regression for predicting success or failure. And they're using a like a kind of adaptive threshold for like score
When
so
you say
that
success or failure, are you meaning does the run crash or do you mean Like, is it
So
solving?
so would this run be so not just crash, but the performance or well below that it should be. So kind of
But
like a
you have a GP
functional.
for score already, don't you?
Uh, so there, yes, but I think like trying to predict score correctly versus would this run be below expectation is kind of different question. So like that's
Hmm. You
one
can try it.
direction. Like yeah, that
I
is so
so
one I like to like explore there,
so my
and
experience
then
with the GPs was just that they're really noisy, right? So it's actually my experience with these is what you want to do is you want to design your algorithm to have as little reliance on the GP as possible, if that makes sense. So like I'm kind of only using the GP to see if it's directionally correct in some way.
mhm.
Um I honestly like
Yeah,
I wish we didn't even need the GPs, but I haven't found any other like model that we can use with this little data.
yeah. So there, like yeah, it could be GP or other classification mechanism
Mhm.
algorithms that is based on hyperparameters that like would
Mhm.
this lead to like somehow the score below like 0.05 or something. So
You can
yeah,
try
that
that and
kind of like
see if it does.
yeah, I will. Yeah, that's
It's very,
that's
very
one
difficult
direction.
that I've seen. It's like very, very difficult. I mean, I guess you could even do like some linear fit, maybe.
Yeah. So like I've been working with Breakout, but like you are suggesting Pong is
Well,
also
Breakout's better,
a good
honestly.
test.
Pong's faster, but Breakout's actually better. So the thing is, Pong is too simple. Um, Typically what I find is that if something is good on Breakout, it's generally good on everything. If something is good on
Mhm.
Pong, it may or may not be good on everything.
But for this particular downsampling, like Pong has that
Yes,
like
so Pong will show you
particular
that
problem.
downsample issue
So
for sure.
mhm.
Yeah.
Okay, then what other environment that you also suggest for testing Swift?
So Breakout is decent because you can get Breakout solves under 30 seconds.
Hmm.
That's decent. We also have the synthetic benchmark. Right there, like all these synthetic
Uh,
tests.
the one you like started with.
Where is it? In test sweep. Yeah, so it's in test sweep. And there's this like little set of synthetic tasks you can use as a
Mhm.
sanity. I did a lot of
Yep.
development on those because a lot of the default like sweep
Okay.
methods will just fail that. And it's
Okay.
like a one parameter fitting task, and a lot of methods will just fail that.
Yep.
So that's a good sanity. I really wish I knew something better to do than just the GPs, but I was not able to find anything better than the GPs. I actually was
Uh,
tempted to do RL, like on all the different training runs, right? But like the
mhm.
thing is that you don't always have the exact same hyperparameters, right? Like sometimes you want to
Yep.
add different hypers in, and it's also hardware dependent. So like it would be better to not have to do that. Um, yeah. I we're gonna get better
Yeah, like
starting hypers at the very least. I think that the goal is we're gonna at least have better starting point hyperparameters for most environments.
mhm.
Um, because what I'm planning on doing basically is part of this analysis is going to be figuring out the range of hyperparameters that like typically work reasonably well for most environments.
Mhm.
And
Yeah. Okay. The environment. So it had like the test suit, like a breakout, home, and yeah. What else? That's
mazes, puffer grid.
mazes,
Mazes is a good
upper
one.
grid.
That's a harder task. Um, yeah, that's a much harder task, and it scales very smoothly. Actually, you can believe it or not, you can kind of tell from the dashboard which are the good ones because
Hmm.
so pretty much the good tasks are the ones where you actually have some sort of slope to the points. Here, let me, where is it?
Yeah. Right.
So when you have some sort of slope to the points, so like you see how like some of these they have like here, I have to improve my colors.
So yeah, breakout was
I'll show
pretty
you this.
steep. So
Yeah, so breakout is not here, I'll show you. Where's the stupid thing? Okay, here. So
and I
yeah,
think
so
you
breakout
mentioned
here does not scale well with
2048.
compute. You see how like steep breakout is? It's
Uh-huh.
basically like you just insta solve with like this very small difference in compute. But some of these
Yeah,
tasks scale
right.
way better because this is a log scale access. Oh no, breakout is good actually. Never mind, breakout's good. Pong is too steep. Yeah. So
Uh-huh.
breakout's actually good. Let's see. Mazes are good. This grid task is good. Where's it?
I think you mentioned
2048 is good.
2048.
Yeah, 2048's
Yeah,
right here. You see
20.
how nice that is? It's this
Uh,
dark blue.
uh-huh.
So this is it's shallow,
And
right?
yeah,
So that means that it
let's see.
actually you get more benefit out of more cost and more steps and stuff, and in like a very smooth way.
And like how long does it take?
Well, I think that I gave most of these a max of like a few minutes per run.
Okay, so 2084. Okay.
2048, yeah. And I can also help you set this up with
2048.
multi-GPU.
Let's do that later.
Yeah.
Like that. I'll so like I think the first thing is to replace a Pyro with GPyTorch, and that will instantly give
Yeah.
us like some like benefit of speed.
Yeah.
And then like after that, like I think we can try like several stuff.
Mm-hmm. That's good. Cool.
Cool. Okay, I'll go off
Thanks,
and
Kyung.
like you have fun.
Thanks. See ya.
Yeah.
Cool. I think I missed a question about SAC, didn't I? Of course. I don't think SAC is better in like any of those cases, honestly. You can look at some of the tasks that we have on Puffer and like on the website, and you can see that we're solving some pretty hard problems that have very sparse rewards. GPyTorch. Well, actually, so you can run Pyro on GPU as well, but I found it was slower for some reason a lot of the time. After the 100th run. Okay, maybe that's what it was. Maybe that was slower first. I'd be happy to have that, though. Answered what question, Convert? Oh, wait, hang on. Damn it. Where's the chat? Question went off screen. I think that I missed a question and I can't see it. You can ask it again if you'd like. I'm gonna use the restroom real quick. I'm going to get another quick set in. And yeah, I guess we continue on this stuff. If you could have a few sets of hypers that get along. Yeah, but you actually have to really understand how everything scales together for that. And it's kind of tricky. So ideally you do stuff like MuP or whatever to make some of the hypers at least a little less fiddly. Like if you could make learning rate less fiddly, that would help a ton. I think that there's some room for some studying of how like gamma changes. Because there's some scaling to gamma. Yeah, mu p. It's like mu, the symbol, and p. If you look that up, it hasn't really been done a lot for RL. It kind of works, but you'd have to integrate it with our muon and test it. Yeah, that would help, but it doesn't help everything. It doesn't help everything. Use the restroom, get a couple sets in, and then I think what we'll do is, yeah, we'll get to the actual cleaning up of this C. We'll fix more things here. I don't know how the hell it's already 2:30. I've just been moving slow today. Shoulder. I don't know what I'm supposed to do if my shoulder's still gonna complain when I put like just 100 pounds on it. I don't know what the heck happened over the weekend. Like, I just posted a couple random things and they both kind of blew up. Like, why the heck does this tweet have 200,000, like 230,000 views? Ridiculous. Actually, wait, I wonder if that qualifies me for, was I pretty close to getting qualified for the premium stuff? Nope. Dang. That's okay. No Elon books for me. Alright, so how do we get the this code to be less of a frickin' mess? Why does it show my gamer tag from 2008? Had a productive day, got ODE physics working. Oh, cool. Welcome, FBR. Yeah, that's a super 2008 gamer tag, my god. It's alright. I had a buddy in high school who had like an account with the username XXNomNomXX. Yeah, but typically you just like pick your normal name and then add some numbers. That's why I have J Suarez 5341 everywhere, right? It's actually super annoying to think of how to compress all this crap a bit, right? I guess, just do... Oops. Let me see. Yeah. 1 second. Yay, I got plates. It's actually kind of annoying to figure out how to shorten this, isn't it? Enter. Oops. Let's see what happened here. Eh? This one? Options. X index. Active, right? Oh, it needs the pointer, doesn't it? Wait, doesn't it need the... Oh. It needs this key reference. So it needs this whole, like, if... Yeah, it needs this like whole mess. Like this, right? Still no? Am I doing something really dumb? Selection. Active. Seems fine, no? That seems weird, doesn't it? Yeah, I see nothing wrong with that. Ah, I see it, dummy. Why do I not get a... Should get a... Well, maybe I did get a warning and just ignored it, honestly. I probably should just fixed all the warnings. Yeah, that's totally what happened, right? Okay. So we get agent steps, cost. What's up with this log thing being weird? It works. Alright, so there's our UI thingy. Right? Now what I can do is I can finally do like this, log Y, log Z, with height. And really, you just need the X and Y, right? So we can just do drop down width 0 like this. Yeah, we can just do it like this, right? X and Y. Just do X, Y, this. Yeah? This is X, Y. Up, down, width. Cost. Okay, so I have this working. This is way shorter. And all I have to do is figure out... There's still some stuff I can do from here, but this is at least something, right? Yeah, it's at least something. Now, I'd love to compress this big chunk of nonsense. Right? This giant chunk of nonsense right here. It's 8. I knew this, right? You can return a static array, can't you? Know why you wouldn't be able to. You should totally be able to do this, right? Oh, but you can't... That's kind of awkward, right? Like, you can get the thresholds, but you can't actually filter. That's super awkward. I guess we can start by getting the thresholds, at least. Yep, that's good. Alright, so now we have our buckets. Big one and index. One color index. Okay, so there are the buckets. Okay, but like the obnoxious thing with this, right? Like the super obnoxious thing about this this is irritating me. Alright, we're gonna chill out and think about this for a little bit. Got one more cup of coffee to go get as well. I'll be right back. Quick set. All right. I know what I'm gonna do. You mute this. Also music on, and let's see if I can. Let's see if I can just actually get myself. Dude, it's like 3, right? Let's see if I can actually get a couple solid hours out of myself on this. Let's see. I think I ought to be able to. I'm feeling better. I think I just had a really slow start today. Because, obviously, I did coding marathon on Saturday and lifting marathon on Sunday. Okay. First things first. We need a way to handle filtering in general. It's annoying because it's in the draw loop, right? I could do the color as scaling instead of bucketing. Yeah, that can just be a straight C map, right? Filter 1, filter 2, C map. Done. Except, does that work? Yes, that actually does work, doesn't it? because you're only ever drawing one track per call, which is the correct way to do it anyways. I'm happy with that. I think that's not terribly gross, right? To just have, like... Oh, you can combine filters, dummy. Filter, CMap. That's actually super awesome. Yeah, no, I got it. I know how we're doing this shit. I need to get myself, a palette first, right? Yeah, let's get it. Best way of doing it. It's Java? What the hell is this? This is totally a grok thing, isn't it? That's actually solid. Look at that. So now I gotta get how to do filter. Oh, and filter is allowed to be null, right? Yeah, even better. Watch this. So I can have the pointer be null. Welcome, Leon. Would you be okay merging? Didn't I already do that, dude? I thought I did that. Oh, I did to less than 2, didn't I? Does it do anything? Like, what's new with 2? Is it faster? Is it better in any way? If you have, like, any sort of experiments that say that it's, like, not broken, then sure. Sometimes I forget how cool this thing is. Dude, look at this. I literally just opened the website. It happens to be Neural MMO on here. Tell me this is not just the coolest damn thing. This is not me playing, right? That's like real RL there. It's freaking kiting with the sword. RL's awesome. Alright, motivation reattained. Let's go. TLDR, yes, will merge if you have some reasonable certainty you're not screwing everything. Okay, that's fine then, QWERTY. I'll merge that. Isn't Muon in Torch, though? Like, isn't it coming to Torch official soon? I saw it in the source. Muon from Torch. Well, it removes a dependency, right? It's probably not going to be better. It's like, I guarantee you they're just going to go look at Lucas's code and copy it into Torch, right? It just removes a dep. bunch of optional things. Well, we'll test both, right? Oh, we were gonna do, yeah, not bucketed anymore, right? X-Men. Yeah, you're just dumb. Let's fix this. I'm just being stupid. Any reason I'm not using CC or codecs? Cause they're shit. I got Super Maven. It's fast, stupid, it helps me type faster, and it gets out of my way. Why would I use something that is a worse programmer than me, and then spend time fixing shitty, stupid bugs instead of writing code? Like, look, I can basically type as fast as I want like this. I was thinking about what to do. Or just scale it, right? Yeah, this is super easy, actually. Yeah, what the hell am I doing? This is so easy. There we go. Yeah, that was way easier than expected. Let's just do this. So now we can give this thing CMap. Null pointer. Oh, and I need this RGB command. See, I used little tiny chunks of AI here and there. And it gives me utter garbage. Because it's stupid. You've got to be kidding me. Ugh. Well, we'll use this for now, but this is like a terrible function. Nice job, Brock. To do slow as fuck. It uses uint 8t's because it's ridiculous. What's wrong with you? Need buckets. Mm-hmm. Let's do like this then. And go in here. Do this. Okay, color param. Yeah, we're gonna clean this thing up, but something like this. Something like this, I think. Uh, don't need this. And affected 9. I messed with this function, right? Yeah. Oh, because I didn't do plot 3. Look at all this code that we get to delete. Look how simple life is. Alright. Plot 3. But we'll figure out how to compress this crap in a bit. But first, this goes here. Went to the gym, took a nap, and you're still alive. Yeah, it's called work. I work all day. It's not even particularly intensive work. This is kind of me just chilling, getting done what I can on like an off day, you know? Let's just do figure 1 first. It'll be easier. No, this is my main thing, dude. Puffer's a company. All my devs open source, but we have clients as well. Ah, easy. Ooh, what do I do for this? Num hypers? Hmm. We'll just do max points. Mm-hmm. The idea around here, right, is this is what I'm doing here. This is a comprehensive effort to advance the field of reinforcement learning, right? There's a company around it, but a lot of what I'm just doing here is pretty much just basic science, a lot of engineering. Trying to put a field back on the map. You know? Hey, boy. Where's the... We looping? What's going on? Is it slow? No, it's not this. How the hell is it slow? Are we stuck in a loop? That's weird. Oh, I'm dumb. Hang on, I'm real dumb. Me dumb. Yo. Alright, it's drawing cubes, right? Yeah, it's drawn. Where are they? You know, these little gaps. What if these are cubes? Yeah, there we go. What's up, Kinvert? Oh. Look at that. Oh ho. Smooth. It was just a struct initialization thing, my guy. Actually, we can figure out how to shorten this, can't we? This block here? Because this code is ass. Let's see if we can figure out how to shorten this up. This is one of those times where I wish I had a list. I guess the simplest alternative would be like... And then this we just take this whole block, right? The thing is, it's like... It's kind of obnoxious to do it that way, don't you think? I kind of hate that. Just push everything into some stupid big function with a million args. Which kind of sucks, doesn't it? Like, this is the right code, I just don't want to have it twice. Oh, I know what we can do. It's kind of shitty, but I know how to do it. Yeah, I know how to do this. Ah. Smoked it. Yeah, that's like the least bad hack, I think. I'll do the exact same thing here. Alright, so let's see what the damage is. Gonna be something similar to this. This. Okay, we do this. This. And then we plot. So, right? Boom. So, some stuff to handle, but at least we have this, like, cleaned. Hot tub stream when? Sorry, that's on the private tab. Those are invite only, in person only. Also, the hot tub is not ready yet anyways. I gotta get some turf installed where it's gonna go. I am actually getting one for, exercise recovery. Alright, so we apply some filters, yeah? And now we no longer need this stupid plot filter function. It's literally just X, Y, false, false, CMap filter. Isn't that nice? Was this apply filter? Filter. Oh, there we go. You set it to 1, not 0, though. Oh, yeah. To fix the color maps and stuff, but that is some solid progress. And then we literally just do the same thing here. Watch me get this entire thing under 1,000 lines feature complete by the time we're done with this mess. It'll be funny as hell. Oh wait, data.n. That's stupid. Yeah, this is better. Yeah, it's gotta be like that. Oh, this is gonna be so much better. Go away these. Oh, and this one just takes a color. It's even easier. No filters. Yeah, so these do actually have to get computed over several M's. So we're gonna have to figure this out. But for now, all right, yeah, like that. So we'll fix up all the colors being weird. Is the restroom get a quick set in? Getting hungry. Alright, so. This has to go into the damn blocks plot, doesn't it? No way around it. Or is there? Hang on. There totally is, right? It'll be a little wonky. I bet you we do it. Let's see. $8.50. I hope you no break things. Hmm. Can I not just do float, like, can I not just do this? Can you not return, an array? I actually don't know off the top of my head. Really? You can't? Bro, that's so obnoxious. That's kind of gross. Why the hell can't you do that? You should totally be able to return that, right? Oh, did I merge your PR or did I, like, get distracted and not? Oh, I did. Cool. Course 860. Try a couple of the other M's. Make sure they don't break. Do not break the puffer or the puffer will break you. You're the puffer. Alright, pull solved. I'm trying to think if there's any. Let's try one of the harder M's, maybe. Probably like grid or something. Grid's usually good. If it crushes grid, I'm happy. I gotta rename that to like maze or something. Wait, Hyperman. Oh wait, am I stupid? I'm stupid. How the hell will grid take 40 minutes? What are you running on? Potato computer? Puffer should be way faster than that, my guy. Alright, this is a consistent color map, yes? Boom, okay. Laptop, lovely. Potato laptop. I merged the ROM-C thing. Eh, fun drivers. Oh yeah, what are we supposed to do for oh, I don't know what this is. How fast puffer grid should run? 185k for me. That seems slow. Oh, it says we're only at 23. Well, according to this, we're only at 500k, though I remember getting like millions before. There's something screwy with this. But maybe yours is right then. I probably have to go recheck. Like, literally, performance just rots over time. Like, dumb little things get messed up, and perf just rots over time. If you're not, actively checking shit. Hmm. Okay, you can't actually do this for, you can't actually do this for CMAP. Yeah, you just have to write a loop. That sucks. Memset works for 0 though. Yeah, I don't either. It's fine. Dude, what the fuck is this shit? Figure 1. Eh? The hell do we do with this? Oh, you dummy. Yeah. Hmm. Yeah, QWERTY. It's alright. I'll help re-optimize at some point soon. It's on the list. It's basically like visualizer and then Optim. This chunk of code needs to get smaller. Kind of tough to figure out how to do this in one pass. I'll get it, just give me a second. Mm. Oh, you know what? Just do this. That's pretty clean, right? At least for now, yeah. I'm better than before. Get all this. All right, let's see if we can get this into the other plots. It's basically the same thing, just with, which means we're gonna end up being able to simplify more, I imagine. Oh yeah, we're definitely gonna be able to shorten this a ton. Array. Yeah. Agent steps. Cost. Ooh. Gotta be fig 2. Yeah, this is better, right? Name. And we can always tone down the neon as well. Alright. So we don't need this. Oh wait, we do need this. We need the env box as well. We need the env box, right? So this basically this entire block, but then it replaces all this. Just like incremental refactoring, really. Cool. Okay. It's getting shorter. Yeah, you need to do this log transform shenanigans, yeah? What to get the C map? Getting bottlenecked by feed forward. No. What would that do? What would that do? Like what? It would scale the batches. Yeah, it would scale it to be less GPU efficient. Then your like you got a profile then because you're bottlenecked by other shit. Like fix your env. Hey, Boxen. Seaport. Well, you caught me at a slightly bad time for it. But we've got a whole bunch of stuff. Yeah, it's going well. So. Not entirely. There is going to be something that you can use instead of Neptune for basic viz. It's not going to have like tracking of individual runs like Neptune does the same way. But this is for larger scale viz that none of these like stupid over-engineered like zero perf web UIs can handle. Also, Constellation is going to be the basis of a lot of 4.0. So there's that. All right, so this is supposed to patch all this. Whoops. All right, like this. Ah. You don't actually need this. Yeah, this has got to be the wrong typing bullshit thing, right? And selection. Do these work? Why are these all focused? Okay, that works, QWERTY. Yeah, so the final eval though is just that. The final eval's an eval. It doesn't have to run training. Yeah, no. There's a lot of stuff I could change with it, QWERTY. Yes. What is wrong with this? Oh, you know what it is? Star. Stupid. There we are. And there's some wires crossed, it seems. But we've got the main stuff. And we've got it to a reasonable length. Most part. The code is at least usable now. Alright, here's the plan. Use the restroom real quick, do another set. And then I'm gonna have about half an hour more on this today. Be good. And we'll get as much progress as we can towards having this thing like reasonable working order. I think we'll get to about 1,000 lines, and then we'll be well set up for the rest of what we need to do. Be back. Shoulder really doesn't like that. Can't even do my presses properly. Where is this bot to ban? Oh, lovely. I don't have the chat loaded correctly, so I can't even ban the bot. Get YouTube open. Do not have YouTube. Well, I can't even ban him on there. It's a Twitch bot, damn it. Okay, hang on. Whatever. Stupid. Can't even get it off the damn screen. Let's figure out what works and what doesn't. Huh. Ah, the logs, right? The heck? Oh, I know. Um, wait. No, this is a bounds error. What? Color. Oh. There we are. There. Lovely, right? And we'll figure out this mess at the bottom. But it's not bad. This needs to have all. This needs env options. What is it? This has env options on it though. So what the heck? Oh, color needs it. Yeah, this gets env options. And then this breaks because we do not have the latest thing for this. Which is literally almost the same code now. Kind of ridiculous. So we're gonna figure out how to combine these, I'm sure. Still under, oh yeah. Well under 1.5. Come on, don't insult me. $10.80 lines. Hyper key. Mm-hmm. I want this shoulder to be functional, damn it. Can't we just, like, make super steroids or something? That you just inject into injuries and it heals them? That'd be great. They're out like 3 or 4 months ago, man. Stupid thing just refuses to heal. It's like this very minor tweak. Like, I can't tell at all during the day, but if I put like 100 pounds up, I can tell. Stem cells. They don't actually, like, go and replace it properly, do they, though? Eh. I would think so. I don't know how much, though. Side sleeper? Sometimes. Wait, how is this 10 thing out of bounds? Hyper key. Is this called hyper key or is it not? Could be hyper key, no? Oh, because it's not. Pick two. Hang on. Hyper key. This is the wrong key. Fuck is this? End hyper options. Look how nice and snappy this is, right? That's how code is supposed to work. It's supposed to just frickin' run immediately. And then we'll figure out what's up with this T-Snake. Oh, we're just not doing a C-map on it, huh? Alright, first two plots are good. Oh, lovely, right? Look at that. Well, we'll see whether it's actually filtering. It's not actually filtering. Figure that out. Get the colors. I think how to do this hyper filter. Well, wait, it'll be the same for both, won't it? Okay, so it is actually doing it. In some way. Oh, wait. Territorium, yeah. I think it's a hack of neural MMO, right? That's definitely like my my tiling logic and stuff, right? Sorry. No, no, the code for the render is definitely straight from neural MMO at the very least. There's literally no way in hell anybody goes to the effort of writing that tiling logic from scratch. It was horrible. Yeah. Yeah, yeah, of course. You're allowed to hack stuff in neural MMO. I'm simply gonna say that's my damn render logic that much. That was hard to write that shit. You go look at the render logic for neural MMO, it's harder than the environment logic. By a lot. Alright, I gotta go in a few minutes for dinner, so, you know, just, before I do, I'll keep on this for a few minutes, but, for the folks watching me here, all of my stuff is right here on puffer.ai. It's all open source. You can help me for absolutely free in 5 seconds by starting the repo. Please do that. You can join the Discord to get involved with development, and follow me on X for all the RL and content, including all my educational stuff and my research articles. Pretty much everything's there. See if we can figure out what the heck is wrong with this filter real quick. Oh. Well, you can't just set stuff to 1 like this. Wait, what? Range. Apply filter. Oh. Yeah, I forgot min and max, didn't I? There we go. Correct way to apply the filters. And then it's probably something like this, right? Well, this is closer at least. But we don't know how to fiddle this. I'm gonna call it here. I will do this tomorrow. We'll have one last little thing to do on this. And then there'll be a little more from here. I'm gonna add this real quick. Oh, and actually, we are gonna end negative lines for the day because this is no longer needed. So we ended in negative line territory for the day, which is awesome. Answer. Yes, Spencer. Yes, Spencer, that's what it means. And we need to chat about that project as well. I'm going to be working on the other one after dinner this evening. Quick look at the seaport, though. Look at the dashboard, man. Look at this. Who needs Neptune, right? After dinner? Yeah, I can do that. I can chat after dinner. Give me, I don't know, 30-ish minutes.